Hello, welcome back to BLENDERSUSHI live noding. In this video, I'm going to share with you kind of like a work in progress Sverchok procedural city, but it's more like a circular kind of city. It's a similar thing to before, but I guess the setup here, the node tree is a little bit more elegant, I think. So in the I'm gonna give a quick rundown. Basically, what we can do with this is we can grow the city. The city itself consists of circles, so it has the starting circle. So I can give the starting circle that's pretty big like that, and then I can kind of make the city bigger like that. So it's like there's like small circle and then larger circle, and we can add more building as we please. And what else we can do? We can adjust whether the city is more dense or less dense from here. Sometimes give error value probably because of this random value, or maybe one of these. Is it because of the seed? Yeah, so I guess it's not 100% perfect, but it's quite decent. I think it's worth sharing, and can change the noise value that's gonna affect the height of the building. So yeah, that might be useful for you. Anyway, I think I will start from scratch and show you the step-by-step progress how I create this. New Blender. It's gonna be Sverchok Circular City demo. Okay, this is the default Blender scene. I'm gonna hide the camera and the lamp M2, put in different layer. Gonna delete the default cube, save, go to compositing. I know that Sverchok plugin is already reloaded. Make sure you have the Sverchok add-on. I have two somewhat. I'm gonna remove one. Okay, save user settings and switch to Sverchok and create new node tree. I'm going to start with a circle and create a fewer nodes so we can see what we are working on. So instead of like a circle with a polygon face like that, the one we're gonna use today is just the edges. The plan is if I draw it real quick using grease pencil, we make like a circle like this. You probably already know how to do this. You can also use a cylinder or any kind of method. And from this circular thing, we want to kind of break it down into separate edges. And then we randomly mask the edges. So that way we get, we have like edges that looks like, like this. And then we extrude the edges that way, and then we just extrude it up. So it's really simple. I just want to show it to you. So maybe you still try to understand Sverchok, or kind of maybe this can help you figure out something else. So this is the circle, and we should plug in the matrix transform to make a complete kind of mesh. Here I know I'm gonna have in order to make duplicates of circles, like multiple circles with different size, we can either use the scale of the transform or use the radius of the circle. Take advantage of this node. So I will definitely use the radius. I know that with Sverchok we can easily just add just plug in list of value. This is Sverchok, so that's how it works. a little bit like let's see if I could think of so it's actually called Gordian, okay, Gordian robot. This is like an anime robot that I used to watch when I was little. The funny thing about this robot is it starts with this human character that goes into the smaller robot. Smaller robot can and can goes inside another bigger robot and goes into another bigger robot. So it's a little bit like in Russia, of course, it's Matryoshka. Matryoshka. I always don't know how to spell it properly. Matryoshka doll. And yep, something like this. So smaller doll goes into a bigger one, goes into bigger. So that's kind of a way of thinking. And if you start with a bigger doll, you know, the bigger dolls might contain many smaller ones. It's like a, so in Sverchok, if you give a list of data into a node, the node's gonna do like some kind of magic inside, and it will kind of uncover smaller data. So with Circle, if we provide it with a range float, and with range float, if I use the stethoscope and look at the data, that's the default. It gives this range of number from 0 to 10. It doesn't have the 10, but it gives you the value between 0 and 10, and the step is 1. The one I like to use is count in this case. Maybe I want to have like 5 circles for now. The circles start from 2, radius of 2, and stop at around 10. And look at the data, 2, 4, 6, 8, 10. This I can plug into the circle, and you might think, okay, I should be getting multiple circles, right? You do have the data. You can see there are 5 data here. But what's missing is the matrix, the transform matrix. We also need to have like 5 data. You can, okay, of course, use a vector and then plug in there. Okay, you have a single data. You can have a list join. Okay, you want to have multiple data. Okay, 5 data. Still not working properly. Why? Because we need to unwrap it or something. We need to wrap or unwrap the data, or change the join list. Now we have proper kind of result. But of course, you can also do it differently. We can use something like random vector. Random vector mk2 is of course giving random value. So if I plug that in and give like a count of 5, you can see this is like 5 different transformations for 5 circles. So they are like all over the place. But they're really kind of a nice way to understand Sverchok. What we really want in this case is just like a value 0, 0, 0 value at the center, and then to make the radius position at 0, 0, 0. So we can basically make the scale 0. See, if I increase the scale a little bit, it gets randomized. Maybe we want that at some point. Maybe I should give that ability. For now, anyway, take care of the count. We know we need to keep the number of count. So 5 or 10 or 100. So now it's pretty easy to do. Okay, we just increase the value like that. Let's hide the points so we see only the edges. Before we get too crazy. Okay, with the, like I said, with random vector is randomizing in all axes. If you really want kind of a slight randomizations, maybe give it a randomize in the x and y. So we can use vector out and vector in, and just plug in the x and y, leave the z at 0, 0, 0. So this is also another way we can give a control to the user at some point. Just like randomization, you know. Make it 0 for now. Let's hide this and hide that thing. We can also randomize the scale and rotation, further randomize the transform, but we don't need that for now. Just a control over the smaller circle and the larger circle, and control over the count. For now, don't be too crazy. Let's give a smaller value like 5. So that's gonna be kind of like a template for our building, like a circular city. Let's save it for now. The next thing we should do is to use masking. There are multiple ways to do this. You can mask just the edges, but you might need to join, because currently we are only looking at 5 circles. There are like 5 different lists. If you're you can either bake this thing and then kind of separating the edges, or we can directly use the vertices and edges masking here using mask vertices. So you can either use list masking, but you need to do a little bit more processing here in order to separate all the edges. Currently we only have 5, so if I'm masking the list, it's only masking the circle, it's not masking the edges. So there's another concept. I'm not gonna do that. I'm just gonna do the mask vertices. That's the easiest way to do it. Vertices to vertices, polygon, actually edges what we want, and this should go to vertices and polygon edge. And hopefully I'm doing it properly. So we needed to have a masking. We need a list of masks here. The list of masks should consist of Boolean numbers. For Boolean numbers, we can use random and math round. It's not round. Let's check the list. Let's delete this. Check the list using stethoscope. So currently we have 1, 1, 1, 1, 1, 0, 0. So this will generate a Boolean list. Okay, that's what we need for the mask. Let's just plug this into the mask. Now we kind of randomizing our circles. Sometimes we have the edges, sometimes we don't. Sometimes for smaller circle we have smaller edges. Maybe you want that, maybe you don't. It's totally up to you. Okay, let's save this again. You might notice that currently we are masking the circle, but each of the mask is pretty much the same. We don't want that. We want kind of a, how can we say, number of edges. Probably the count should be based on the number of edges. Let's try list length. The data come from edges, and let's check the stethoscope. It says 5 edges. Not really 5. No, 2. Yeah, this is slightly tricky because we don't have 5 edges. We actually have a lot more edges. Maybe I need to use something else, but for simplicity, I really just gonna randomize the seed. There's gonna be a problem with the count. It's not changing correctly depending on the data we're putting in. But anyway, I just want to randomize the seed, okay, for each circle. So just use a list integer range. For the count, I'm just gonna use this count from here. Plug this into the seed. Now I think that should be alright. It's taking care of the randomizations of the mask. Okay, that's still working fine. Smaller circle working fine, larger circle, and we can have more or less. So that's good. Let's save this. Now the next thing we need to do is just to extrude these edges. And to extrude the edges, we have Extrude Ages, which is this funky node right here. It's not like the normal edges. I wonder if there is a normal edges in Sverchok. I don't know, but this one is a little bit funky because you can control each vertices. You can randomize the vertices. We can have this. We can use this matrix in. Basically, for simplicity, just do it like this. Oops, not scale. Vector in. Just provide a single scale value. Okay, that gives us that, but we really just want to extrude the edge out a little bit, like that. Okay, we actually still have control over the count of the boolean, maybe more or less random. Somewhere in between. Okay, that looks pretty good. Yeah. Next thing we need to do, let's save this and save again. Sverchok is, I think, there's the latest updates should make it more stable. It shouldn't crash anymore. If there's a crash, just report it to Sverchok developer at GitHub. The next thing we need to do is just use something like extrude separate faces. So this is nice. This is like nodes like this, extrude edges, extrude separate faces, give us control over the extrusions and for edges and faces. It's pretty easy to generate cool stuff now. The height, okay, currently they have the same height. A little bit concerned about the small circle because it has smaller edges. I wish but for now it's okay. So we'll figure that out later. Scale give us control over the extrusion local scale. You know, maybe that's what you want. Leave it at 1. The height, we know that we want to randomize the height as well. But the thing here, I don't know how many faces we have at the moment. Maybe we can check it here. List length. Check the new faces here. Stethoscope. That's the index for the face, but we have multiple, of course. This give some value. Yeah, I have to ask the Sverchok developer, I think, how to get to the number of the face. The only way I could think of is to actually, if we apply matrix to mesh, if we are doing it like this, I'll show it to you. Plug in the vertices there, polygon there, and the matrix is there. Here, we can actually count the number of faces, for example. Here, if I disconnect this and drag this there, plug in the faces. and check the number of data. It still says 5. Matrices. Let me check. Join. Join should be on. Okay, 915. That's a correct number of phase actually. So if we really want to have random height for all the faces, we need to plug in that number. Yeah, apply. Because currently we are using viewer draw, and to draw all these polygon structures, this guy actually kind of baking it out, and we can tell the correct number of faces. So we can use this apply matrix to mesh nodes a couple of times in order to get the exact count. But I'm not, I don't worry about that. I just delete that for now. I'm gonna give just a random number. So random node. Plug this into the height. If we plug this into the height, you see we have and give it a count. We can have a random height of building. Some of them actually pretty flat, which is okay. Maybe flat building is like a park or something. But if we really want, we can use map range. So instead of random value 44 random value, we can have a random number between maybe 1 and 10. So 1 and 10, how many count? We know that we have over 900 face, so we can give just a random count, which is okay. It's kind of still giving us a result. What will be nice is actually for all those faces, we kind of grab the center of points, and so we know, and from that center points we kind of maybe control the points using textures. I kind of at this stage a better way is to have control over the building height by using like a mapping, like an image map, maybe using vertex weight or texture color. But for simplicity, I'm not gonna do that. We're just gonna do it like this. A better way is, instead of using random, is just maybe use the vertices. Vector noise. There you go. Vector noise. Like I said, if you want to be more elaborate, you want to get the number of polygon face and get the center of each polygon and plug the center of each polygon into the vertices. For now, we're just gonna cheat and plug in the vertices there. So there's gonna be an error. There's gonna be an error with a number here, but that's okay. You're still gonna get results. That's like a noise value affecting our building. Oh, it's actually giving us error already. It doesn't like the vertices that we give. So center polygons, normal origins. Well, you know what? I think I will just use apply matrix to mesh. Plug this into, plug this guy into that guy. Plug the polygon there. provide the matrix and get the center of each polygon and plug this into the vector noise, and hopefully Sverchok is happy with the number. Still kind of fail. Let's check the data noise. It's actually okay. I know why. That's because I'm plugging in vector data into map range. That's wrong. Needs to be scalar. Now it's correct, and I can plug this into the map range. And let's check at the noise value with the stethoscope. Oops, Sverchok crashes. That's okay. I already saved it. Let's reopen Blender. Show package content and rerun Blender through the terminal. Okay, we got it back. We open the city example, save as new file. Cool. Now let's cut this for now. Let's cut this. Switch to scalar once again. Switch this to new Perlin. Maybe get the origin. Plug this into the noise. Don't crash. Plug this into the height. Okay, that's it's working slightly better. Let's see how we can have a look at the noise, and maybe we can kind of move the noise so we can use a vector math. Separate. Do we need to separate it? Yeah. Vector in. Plug it in. I'm going to frame this. I think Control J, and that's for our noise. Basically, get the center of each faces and then randomize. Now that we have this control, we can randomize the building. We are randomizing the noise basically. Can do it using frame. So for every frame, I'm generating new building. Let's stop that. Okay, so that's cool. Let's we know that we can randomize, slightly randomizing the circle, kind of shifting the building. Okay, so it's not fully circle, which is nice. Now we know we can make the building like more dense. With the circle, we can also control that the size of each circles. You can of course further make changes, kind of like for the extrusion. Maybe you want to randomize the extrusion. That's this building in the center is kind of small, but that's probably okay. Yeah, I guess that's pretty much that I want to show you. The last thing is if I'm baking this, the result is gonna be it's separate building. Oh, of course, it has a slight variation. It's still keeping the circle, which is nice. You can definitely use this. Maybe arrange it. I want to make quick arrangement. Let's use animation nodes, template, grid arrange object, group this guy, objects in, objects from group, get the group, plug in the group into object list, delete this guy, delete that guy. Increase the distance of grid 10, 20, 40, and yeah, that's more like see what I did here is kind of putting each building into a grid, but you know that's this kind of look also quite interesting. Hey, I lost view view all. There you go. That's actually kind of nice. I wonder if there is a city that's kind of being scattered like this. That's a small buildings over there. Suspicious building with that kind of configuration. But that's that looks like more like a city, even though they're just boxes. But I found that you can turn this into like a stack objects, but really the stacking you can just use cycles texture to fake that, and the windows and then all the doors should be using procedural textures, and the ground yeah, whatever. I'm gonna delete the animation nodes, back to Sverchok. One more thing I want to show you, instead of having all separate buildings, you might also, and instead of using bake, you might also want to use the objects in MK2. Oh, actually wrong. Use a BMesh viewer MK2. Plug in the vertices, plug in the faces, and plug in the matrix from this guy to that guy. Hide the viewer. Now we have a real city, and they are still alive, controlled by this viewer BMesh. I like it how it has this colorization now. You can use matcap because it looks good. Ambient occlusion, metallic city, dark city, but this is still alive, and we can further increase it like 50 times. Maybe we have 500 building at the moment. It's too dense, but that's all right. That's a super dense city. I don't know if city of Paris is like this. It's made of circular kind of format. Currently, I think the only issue is the smaller circle have smaller building like that, and the edges seems to be still still getting larger. But anyway, back to previous. Every frame will actually update the city, and we know that we have control over the height of the city as well, somewhere here. New minimum, new maximum. Maximum can be 25. So some buildings will be taller. 60. Yeah. Circular city, new of futuristic city. the next thing we need to take care, maybe the suburbs, smaller kind of houses. The center is a bit weird. Maybe we need like a park. Some of the buildings should be like tiny, like that. Yeah, that's I guess that's quite nice. The fact that we can do this quite easily. I will give away this setup as a gift before I forgot. Export to GIS, export, and save this as SV circular city rough. Save. It's gonna be the JSON. I'll put it in the GIS at GitHub, and then you can download the ID and you can reload it, and you get this city basically. Okay. Hopefully you find this video useful. Leave a comment if you have any questions. And thanks again for tuning in to BlenderSushi channel. Please subscribe to keep the channel going. Yeah, that's all. I'll see you in the